Good morning, 12th class. Today our topic is abnormal molecular mass. Okay, this topic is important because after this topic I'll explain Vent off factor, and that one is very important for your board exam as well as for your competitive exam point of view. Okay, so first of all understand this because important. Now, abnormal molecular mass. Okay, according to their name, definition I'll explain later on, but first of all normal one. Okay, according to their name means whatever is the molecular mass of the substance, and if abnormal is added, it means whatever is expected, okay, it is different from the expected one. Okay, for example, एक जनरल सा एग्जांपल ले रहे हैं. Okay, now suppose if I'll see someone या हम किसी को देखते हैं. Okay, after that we'll say कि okay, my god, this one is very thin and slim or जो भी. Okay, so their weight is around 50 kg. Okay, but actual में जब हम उसका weight लेते हैं तो maybe it's around 70. Okay, then we said what? Okay, bones का weight होगा या कुछ भारी होगा. Okay, तो it means that weight is totally different from their expectation. या कभी कोई बहुत healthy इंसान होता है. Okay, we'll see. Okay, ये तो बहुत ही weight ज़्यादा होगा इसका, लेकिन जब actual में weight लेते हैं तो generally the weight is comparatively less. Okay, तो all these are abnormal masses basically, मतलब whatever is looking या जो दिख रहा है basically it is different. तो same condition with molecules also. Okay, so there are sub abnormal molecular masses also, and how this thing is happen, that also I'll explain to you. Now first of all, abnormal molecular mass. Okay, actually when the molecular mass of a substance determined by colligative properties, whatever is the colligative properties, either it's a depression, either it's elevation in boiling point. We have 4 colligative properties. Okay, so when the molecular mass of a substance determined by colligative properties comes out to be different from theoretical expected value, okay, the substance is said to show abnormal molecular mass. Okay, when they are showing different values as the different mass as comparison to expected, so that one is known as abnormal molecular mass. Okay, now question arises, why this abnormal molecular mass hota kyun hai? Okay, so this one is just because of molecular association or dissociation, or when the solution is non-ideal and concentrated. Okay, actually what happens, sometimes it happens that when we add some molecule or solute particles in a solvent, then either they associate in that case, or maybe it dissociate. So that's why just because of that one molecular association and dissociation, they show some molecular, okay, abnormal molecular mass. Okay, so to calculate the extent of association or dissociation, kitna associate or dissociate हुए, when an electrolyte is dissolved in solution, okay, Van't Hoff, okay, introduced a factor, that one is known as Van't Hoff factor, that I'll explain after this video. Okay, that one is Van't Hoff factor. Now I'll explain molecular masses and how they affect. So first of all, okay, you have to learn one term, that one is molecular mass of solute. That one is inversely proportional to 1 upon delta. This delta represents colligative properties. Okay, whatever is the colligative property, that delta is represented, this represent colligative properties. That one is again inversely proportional to number of particles of solute in solution. It means more is the number of solute, no more is the colligative properties, but less is the molecular mass of solute. Okay, so now you know abnormal molecular mass is because of molecular association or dissociation. So first of all, I'll explain association of solute particles. What happen when you will add some substance in solvent, okay, then either it goes under association or dissociation. So first of all, association, basically what's the meaning of association? Association means it's a binding, combine ho rahe hain, combination. Okay, so now in case when 2 or more molecules of solute combine together in solution to form aggregates, okay, maybe it's a dimer, trimer, polymer, okay, it depends. Now suppose you can take example, any general example. Okay, that one is, suppose it's a benzoic acid, formula C6H5COOH. Actually benzoic acid, when you add in water, it goes under molecular association, okay, and form dimer. Dimer means when two molecules of this one is two molecules combine together and form one single, okay, molecule. Now just see in this one, that is C6H5, that C you can write like this also, it's a OH. When it combines, so generally when it dissolved in water and some other thing, so then what happened, it undergoes molecular association. Now just see, this one is C6, now this is O, this one is H, this one is double. Now this is partially negative, this one is partially positive, partial negative, partial positive. So between this, generally they associate with the help of hydrogen bond. You know hydrogen bond, it's a strong bond and represented by dot. So this is hydrogen bond, so they form a dimer. You see, they form a dimer. Now in this case, what happened, previously two molecules are there of benzoic acid, okay, when dissolved in a solvent, then it forms a single aggregate, इसने dimer बना दिया, okay. Now in this case, what's the effect on molecular mass? So you can easily identify what's the effect on molecular mass. Now just see, okay, previously it's two molecule, okay, or maybe I'm just giving example of two only, okay. Now in this association means large number of particles, okay, converted into single one. So molecular association leads to decrease in the number of particles. Previously it's two, after becoming dimer it become one, so there is a decrease in number of particles of the solution, and just because of that number of particles decreases, it means their colligative properties also decreases, and hence their molecular mass is more as comparison to expected, okay. So in this case, molecular association, now just see, in this case always leads to the higher value of observed molecular mass. Why? Number of particle is decreases, colligative properties also decreases, so this one is inversely proportional to their molecular mass increases. So this one is the effect of molecular association. Now in this one is corrected by Vent-Off factor. Generally Vent-Off factor is represented by I. So in case of molecular association, this Vent-Off factor I is less than 1. This one is less than 1. Now next is, it's a dissociation of solute particle. Now simple thing, you know, when we add, either it's a salt, maybe it's a NaCl, maybe it's a KCl, okay. Now when you add in water, or either it's a aqueous solution, okay, this one is aqueous solution, it means we are adding this in water. So you know this one KCl is solid, when it dissolved in a solvent, aqueous solution, this one is a solvent, when you dissolved it in a solvent, what happened, it dissociate into K positive plus Cl negative, both are in aqueous form because they dissociate only in, okay, aqueous form. Now just see, K positive, Cl negative. So previously the number of particle is 1, but after dissociation the number of particle become 2. So what's the effect on molecular mass? Now in this case, number of particle increases, it means their colligative properties also increases, which always leads to the lower value of observed molecular mass, okay. So in this case molecular mass is decreases, yeah, lower as comparison to expected. So in this the value of I is greater than 1. So this one is regarding to molecular association and dissociation. In next video I'll explain Vent-Off factor. Okay, thank you.